Hello, my name is Argun. I'm from Bilkent University in Turkey. In this video, I'm going to demonstrate my term project from my course EE 102, Introduction to Digital Circuit Design. For my term project, I designed a parking sensor, which consists of a parking mode. I designed my project considering a real car. So when this parking mode is on, the winkers of the car should start winking to inform the others around that the car is going to park, and also the distance from the car to the closest object should be displayed on the screen. And when this mode is off, the winkers should stop winking, and then there shouldn't be any display. However, if the distance is less than 10 centimeters, the distance is shown just to warn the driver that there is an object close to the car. Let me show you how my distance sensor works. So here this switch controls the parking mode, and as you can see it is off now, so there is no display and also no winkers flashing. But as I bring an object closer, as you can see, now there's a display. It is shown since the distance is within 10 centimeters range. As I bring the file closer, it starts decreasing. It shows 2 centimeters minimum because my sensor cannot perceive a distance less than 2 centimeters. As I toggle the parking mode on, the winkers start winking. There are 12 LEDs and they all work since the distance is greater than 60 centimeters. If an object is bringing closer than 60 centimeters, they start going off each 5 centimeters. So the distance is shown as 888, meaning that there's no object within the range, which is 100 centimeters. But as I bring my file closer to the sensor, you can see the distance is displayed. And now the distance is less than 60 centimeters, so each 5 centimeters these LEDs start going off. The winkers continue winking. This is the minimum distance. In the previous demonstration, when the mode was off, the anodes of the 7-segment display blink when the distance is about 10 centimeters. However, they were supposed to show no display, so it was a bug, and it was due to very frequent updating of the distance. For calculating the distance, I used counters that count to the actual distance, and since this process is very fast, no matter if the distance is about 10 centimeters, there is a display on the 7-segment display that shows the counting up to 10. So in order to debug this, I used a clock divider. This part of my code divides the clock of the FPGA. In order to debug my project, first I defined a signal called CLK slow, and each 15 milliseconds, which correspond to 1.5 million pulses of the clock of basis 3 FPGA board, this signal changes its value. So here I created another clock of period of 30 milliseconds, and then I defined a new variable called final dist, and instead of assigning it a value at each rising edge of the clock of the FPGA, I assign it the value of the calculated distance at each rising edge of the CLK slow, which is the newly formed clock. So with this addition to my code, I update the display on the 7-segment display less frequently. So I debug my project using a clock divider, and here's the demonstration of the debugged version of my project.